Welcome back to the deep dive. Today, we are opening a file that feels less like a technical manual and more like, I don't know, a manifesto from the future.
It really does.
We are unpacking something called the Fractal Platform. And I have to say, right off the bat, the promise here is it's aggressive. It is incredibly bold.
Oh, it's incredibly bold. I
Yeah.
mean, when you read documentation that claims it can cut your code volume by 10 to 100 times, your skepticism meter, it just naturally spikes.
Yeah, and do 100 times.
Yeah. We're talking about a hello world application that's one single line, or a fully functional Netflix-style cinema application in 40 lines of code.
40 lines. I'm pretty sure I've written configuration files longer than that just to get a server to say hello.
Exactly. And usually when we see claims like that, our first thought is, okay, this is a toy.
Right.
This is a low-code wizard that works great for a bake sale website, but it's going to fall apart the second you try to build a real enterprise system.
And that's the developer's dilemma, isn't it? I think we've all felt it. You're sort of stuck between two pretty bad options.
You really are.
Option A is, traditional coding. C#, Java, Python, React, whatever your flavor is. You have total control. You're the god of your machine. But you are spending weeks, sometimes months, writing plumbing.
Oh, the boilerplate fatigue is real.
So real.
You're writing thousands and thousands of lines just to get a piece of data from a database onto a screen. It's maddening.
It is. And then you have the other option.
Right. Option B, the modern low-code or no-code movement, which sounds amazing on paper. Just drag and drop, build an app in an afternoon.
The marketing is fantastic.
It is, but in practice, it feels like building with Legos. You can build very, very fast, but only if you're building exactly what the Lego kit was designed for.
Yes. The moment you need a piece that doesn't exist in that box.
You're stuck. You've hit a wall, and then you're trying to hack it, and it all falls apart. And that is the core analogy that the source material we're looking at today leads with. It's the perfect way to frame this entire discussion. They say traditional low-code is a Lego set. It's rigid. Fractal, on the other hand, positions itself as a 3D printer.
I love that shift in perspective. A 3D printer doesn't force you to go searching for a pre-made part that's almost what you need.
No.
It just prints the exact part you need, mathematically perfect, for the exact slot you need it to fill.
Precisely. And the mission here, and this is based on the concept.md architecture guide, and this just fascinating philosophical piece they wrote called Programming That No Longer Exists, is to introduce a system where you aren't just writing code, you're configuring behavior.
Configuring behavior.
But not in a black box kind of way where you don't know what's happening. You're doing it in a way that's fundamental to the very structure of the data itself.
Programming that no longer exists. I mean, that's quite a title. It sounds almost ominous, but also kind of liberating.
A little of both, maybe.
Yeah. So let's unpack this. We absolutely have to start with the name Fractal. When I first saw this, my first thought was, okay, are we doing geometry now? Are we looking at pretty spinning shapes on a screen? But this isn't just a cool brand name, is it?
No, not at all. It's actually quite literal. And this is the specific focus we really need to drill into, because I think if you don't understand why it's called fractal, you won't understand why it works. It describes the literal architecture of the data.
Okay, let's go back to high school geometry for a second then. A fractal is a self-similar shape, right? Like a fern leaf or a snowflake. If you zoom in on a tiny little tip of a fern, it looks exactly like the whole fern.
Recursion. That's the keyword. Infinite recursion. The fractal platform takes this concept, this geometric idea, and applies it to database architecture.
How so?
Well, in a traditional system, you have a very strict hierarchy, right? You've got your database, which has a table, which has a row, which has a column. It's rigid.
Right.
In Fractal, you start with a collection, which contains documents.
Okay, so far, that sounds a lot like a standard NoSQL database, like MongoDB JSON documents in a collection.
It starts that way, yes. But then it gets interesting. Those documents are wrapped in what they call dimensions.
Dimensions.
And dimensions are basically metadata and rules. Think security rules, validation logic, UI instructions, that kind of thing.
Okay.
But here is the recursive twist. This is the aha moment from the documentation. A dimension is also based on a subdocument.
Wait, hold on. Say that again. So the rule that governs the data is also data.
Yes, exactly. The configuration for the rule is just another JSON document. And because that rule is a document, it can have its own subdimensions.
No way.
And those subdimensions are documents, which can then have their own subdimensions, and so on and so on.
It's turtles all the way down.
It is fractals all the way down. Theoretically, you can drill down infinitely. Every single layer of logic, whether it's checking if a user is an administrator or determining the color of a button on the screen, is just another document with its own properties,
Yeah.
structured in exactly the same way as the parent data it's describing.
So instead of having a SQL database over here, a C-sharp backend over there, a React frontend way over there, and then a whole mess of spaghetti code and API calls gluing them all together. It's all just this one unified, self-similar structure.
It's all the same mathematical model. That's what the creator calls CMDD Common Multidimensional Design. It's like the unified field theory for the platform.
A unified theory for software.
And the practical upshot is huge. If you know the syntax of JSON, which every developer does, you already know the configuration syntax for all 57+ dimensions available on the platform. You don't need to context switch between 5 different languages and frameworks.
That is a massive, massive claim. Okay, before we get completely lost in the abstract geometry of it all, we need to ground this. What does this actually feel like for a developer? Because the source material, it paints this picture of an ideal day that, honestly, it reads like developer fan fiction.
It really does. It's the absolute perfect world scenario.
Yeah.
But it serves to illustrate the efficiency of this pipeline. So let's walk through it. It's 9:00 a.m. You wake up with an idea.
Okay.
Stick with a classic example.
Yeah.
You want to build a social network. Not even that complex. Just a forum for, say, cat lovers.
A forum for cat lovers. I'm in. Okay, 9:00 a.m. In my current life, that means I'm spending the next 3 hours setting up a GitHub repo, installing a mountain of Node.js packages, configuring a database server, and fighting with connection strings.
Right. All of the plumbing.
Yeah.
Hours of it. In the Fractal world, 9:00 a.m. is design the data model.
Yeah.
You open the editor, and you just start writing JSON. That is it.
No servers, no setup.
Nothing. You just define your entities. You'd have users, posts, comments, and then you define the fields inside them. Name, photo, timestamp, content.
So it's just text, just keys and values in a text file.
That's the entire foundation. Now here's where the speed really comes in. The documentation says that by 12 p.m., by noon, 3 hours later, you have a working prototype. And I don't mean a wireframe or a sketch. I mean a functioning application.
Hold on a second. You've only written JSON?
Yep.
You haven't written a single line of HTML or React or anything. You can't click on a JSON file. How's that an app?
This is the first major sort of magic capability of the platform. It generates a full Sirad UI create, read, update, delete automatically based only on that JSON data model you wrote.
How does it know what to draw on the screen?
It infers it from the data types. It looks at your JSON, it sees a field called name, and it sees that it's a string type. So boom, it gives you a text box. It sees age as a number, so it gives you a number input with the little up and down arrows.
And isAdmin is a Boolean.
So it renders a checkbox.
Exactly.
An array of subdocuments becomes a grid or a table you can add rows to.
It's that 3D printer analogy kicking in right away. It's printing the interface based on the shape of the data itself.
Precisely. And this is so crucial for what they call internal screens. Think about it. How much time do developers waste building boring, ugly admin panels just to manage data in a database?
So much time. It's the least fun part of any project.
Fractal gives you all of that for free, instantly. So by the time you go to lunch, you're already showing your colleagues a working app where you can actually create new users and save posts about cats they can use.
Okay, that's a pretty compelling morning. So lunch is over. It's 1:00 p.m. now. I have a prototype, but it's dumb. It's a free-for-all. It lets anyone do anything. This is usually where the simple low-code tools completely break down.
Right, this is where the real work begins.
I need actual business logic. I need to make sure only I can delete the really cute cat photos. I need validation to make sure people aren't posting empty comments. I need localization because my cat lovers are also in France and Japan.
This is the adult software phase, and this is what occupies the afternoon, from roughly 2:00 p.m. to 6:00 p.m. In a traditional build, this part would take weeks, if not months.
Easily.
In Fractal, you implement this logic using dimensions.
Dimensions. Okay, so we're back to the layers, the fractal part.
We're back to the layers. You aren't writing a bunch of spaghetti code inside a controller file. You aren't writing if user as admin nested 10 levels deep inside a function. You are adding configuration layers to your data.
So you just add a new file.
You add a new dimension to the JSON.
Wow.
You want validation. You add a validation dimension. You want security. You add a security dimension. You want a localization. You add a language dimension. And the claim is, by 6:00 p.m., you deploy to the world.
One day. From an idea in your head to a deployed, secured, localized, functioning application. That is the pitch.
That is the pitch.
Mm,
And it really challenges our fundamental assumptions about what code even needs to be.
mm.
We're so used to code being verbose. We're used to describing how to do every single little thing. Open a database connection, query this table, format this string, check this permission, close the connection.
It's all procedural.
Very. Fractal wants you to just describe what you want. I want a secure list of users. And the fractal architecture itself handles the how.
It sounds a bit like we're moving from being, I don't know, construction workers who are laying every individual brick by hand to being architects who just draw the blueprint and the entire building just manifests itself.
That is a very, very apt comparison. But to really trust this architect, we need to understand the materials. We need to understand the blueprint language.
Right.
So we mentioned there are over 57 dimensions. So that's a lot of dimensions. I thought we only had 3 spatial ones and maybe time.
Right. It sounds completely overwhelming. But let's look at the big hits, the dimensions that actually change the way you work day to day. You mentioned security. How does that actually look in this JSON structure?
Okay, so this is a great example of what they call aspect-oriented logic. In traditional coding, security is what's known as a cross-cutting concern.
Meaning it cuts across everything, it touches every part of your code?
Exactly. You have to sprinkle security checks absolutely everywhere. Every single time you write a function to save a piece of data, you have to remember, oh, I need to check the user's permissions here. If you forget just once, you have a security breach.
It relies on human memory and discipline, which are, let's be honest, notoriously unreliable, especially on a Friday afternoon.
Exactly. In Fractal, you separate the scenario from the aspect. The scenario is the pure action. Save this user. It's one line, crystal clear. The aspect, in this case security, is a dimension that wraps that scenario. It's external to it.
So the save function itself doesn't even know that security exists.
It doesn't need to. It has no idea. The platform handles it. When your code tries to access the data, the platform intercepts that call and checks the security dimension first, like a pipeline or a series of gates.
And does that go deep? Like, can it control individual fields?
It goes very deep. The security dimension can handle field-level permissions. You can write a rule that says everyone can see a user's name, but only users in the admin role can see the user's salary,
And you do that just with JSON?
just with a JSON configuration. And you can even do things like data masking. The source material mentions masking credit card numbers. You just define a regex pattern in the security dimension, and the platform will automatically show something like asterisk, 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 asterisk 1234 to any unauthorized user.
So you don't have to write a masking service class or some special formatting function.
You just configure the dimension. That logic is now a property of the data itself.
That is huge. Okay, what about validation? I feel like validation is at least 50% of the code I write on any given day. Checking for nulls, checking string lengths, making sure an email looks like an email.
The validation dimension is probably my favorite feature because it solves what I call the double work problem.
Oh, I know this one.
Right. Usually you have to write all your validation logic twice.
Yep. Once in JavaScript for the browser. So the user gets that immediate feedback, like a red border on the input box if they type too many characters.
And then you have to write the exact same logic again in C# or Java or SQL on the back end to protect the database from malicious API calls or just bugs in the front end.
And if you change one and forget to update the other, you have a bug. It's a constant source of problem.
A constant source. In Fractal, you define the rule once. In the validation dimension JSON, you write max length 50.
Yeah.
That's it. The platform automatically enforces this on the storage side. The database will reject any string longer than 50 ND. It automatically generates the front-end restriction.
So the input box on the web page physically stops me from typing at 51 characters, and the database will reject a direct API call with 51 characters, all from that one single line of config.
Correct. It derives both behaviors from that single source of truth.
That is genuinely elegant. It just eliminates a massive class of synchronization bugs right off the bat.
It does. Then you have things like the reference dimension. This handles relationships between documents. It's like foreign keys in SQL, but more powerful. It lets you create links between, say, a user document and a post document.
Okay, that's standard.
But it allows you to work with the reference attributes as if they were local to the document. So you can query for a post and just say post.user.name without doing a separate join or a second database lookup. The dimension handles the fetching in the background.
It simplifies the query logic a lot.
Massively. And then you get into the more exotic dimensions like the theme and language dimensions.
What do they do?
With the theme dimension, you can change the entire UI color palette of your application, dark mode, blue mode, a custom light pink mode dynamically, just by changing a setting. The language dimension lets you localize the entire app into multiple languages without changing a single line of your core code.
You just provide the translation files as another document.
Exactly. You wrap your app in that dimension, and suddenly every label, every button, every tooltip can be displayed in English, French, or Japanese.
And all of these dimensions, they're all just JSON files that follow that same recursive structure.
All of them. And that brings us to the integration dimensions, which are maybe the most powerful of all.
Integration, so connecting to other systems.
Yes. For example, there's an RDBMS dimension. This one is incredible. It can map your JSON documents to traditional SQL tables in MS or PostgreSQL automatically.
Why would you want to do that? Isn't the point to get away from SQL?
For analytics or for legacy integration. Maybe your company's business intelligence team only knows how to use SQL tools to run reports. With this dimension, you can give them a live, relational view of your NoSQL data, updated in real time without you having to write a complex ETL pipeline.
So you get the development speed of JSON documents, but the business team gets the SQL access they're used to.
Exactly. There's even an Excel dimension that can synchronize a collection directly with a spreadsheet. You could have a non-technical user manage a price list in Excel, and every time they save the file, it updates the live data in your application's storage.
That's wild, but doesn't adding all these layers, all these dimensions, slow everything down? It feels like a lot of overhead.
That's the pipeline efficiency they talk about.
Yeah.
It's actually the opposite. It's not just for organization, it's for performance.
Yeah.
If a specific data collection doesn't need, say, the transaction dimension, then that logic is never even loaded into memory for that collection. There's zero overhead.
Ah, I see.
You only pay computationally for the dimensions you actually use on a per collection basis. It's incredibly granular.
Okay, so that's the logic. Let's talk about the data itself. Because throughout all the documentation, they seem almost allergic to the word database. They keep calling it storage. Is that just them trying to be fancy and different?
No, it's a very deliberate and important redefinition. They argue that what we typically call a database, like SQL Server or Oracle or even MongoDB, is actually a bloated, monolithic piece of software. It's full of query parsers, network listeners, transaction coordinators, and decades of legacy overhead.
It's trying to be everything to everyone.
It is. Fractal defines storage as a minimal, pure algorithmic unit for key value storage.
So it's a small building block, not a giant monolith.
Exactly right. And because of that, you can mix and match them. You might have one collection in your cat lover app that is optimized for writing, like a log of user clicks or audit trails. For that, you would use a storage engine that's designed for ultra-fast, append-only operations.
And for something else.
Another collection might be your product catalog, which is read 1,000,000 times a day but only changed once a week. For that, you would use a completely different storage engine that is heavily optimized for fast reads and high data compression.
And these can coexist in the same application, managed by the same platform.
In the same app, under the same unified logic. The source material claims that a functional, production-ready storage engine in Fractal can be written in just 300 to 400 lines of code.
That is tiny. That's smaller than a single feature in most big frameworks.
It's minuscule. They argue that pure data structures, like a hash map or a B tree in memory, are the fastest database in the world. Everything else is overhead. Fractal tries to strip all of that away unless you specifically request it by adding a dimension.
So if I want raw screaming speed, I can use a bare bones storage. If I need features like transactions or full text search, I just layer them on as dimensions.
You got it. You build the database you need for the job instead of trying to fit your job into a pre-built database.
And to query all this, they use something called DQL document query language. Please tell me it's better than SQL. I have such a love-hate relationship with SQL.
It's described as an analog to LINQ, if you're familiar with that from the .NET world. It's very different from SQL. It allows you to filter, extract, and modify data using functional chains.
What does that look like?
So instead of writing a big declarative SQL statement like select name, age from users, where age 30, you would chain methods together in your code. It would look something like doxoff. Users, where
Correct.
user.age30. Select user.name, user.age.
Ah, so it looks and feels like the rest of my programming language. It's not this separate string I have to build.
Exactly. It's very intuitive for developers because it is code, not a query string. This also means you get compile time checking in IntelliSense, which avoids a whole category of runtime errors from typos in your SQL.
Okay, this is all making a lot of sense from a backend perspective. The recursive structure, the logic dimensions, the flexible storage. But now we have to talk about the elephant in the room, the thing that users actually see and care about, the UI.
Front end.
Because you said the prototype is automatic, and in my experience, automatic is a synonym for ugly.
It usually is, and Fractal absolutely acknowledges this. They don't pretend that the auto-generated UI is going to win any design awards.
Yeah.
That's why they have what they call the makeup philosophy.
Makeup. I love that term. It implies the bone structure is already there, and it's good you're just making it presentable for the public.
That's exactly the idea. They propose a triad of UI creation, 3 distinct levels you can operate at.
Okay, what's level 1?
Level 1 is automatic. That's what we discussed for the morning prototype. Write JSON, get a form. Primitives become text boxes, Booleans become checkboxes, arrays become grids.
Perfect for the admin panel, terrible for the customer-facing homepage.
Right, it's for your internal screens. So then you have level 2, customize standard. This is where you use the UI dimension.
The UI dimension, another layer.
Another layer. This lets you tweak and enhance the standard controls. Maybe you don't want a standard text box for the content of a post. You want a rich text editor with bold and italics. You can specify that in the UI dimension.
Okay.
Or maybe you have a string that's actually a URL to an image. You can tell the UI dimension to render that string as a picture control that displays the image. You can add tooltips, wizards, tabs, pagination, all through their own respective dimensions.
So it's still sort of a grid-based, form-over data layout, but it's much smarter and more user-friendly.
Exactly. But then you have level 3, raw UI, the makeup. This is the answer to the, but what if I want my site to look like a polished consumer product, not a database admin panel question?
What is the answer?
The answer is you can take any HTML and CSS layout you want and use it.
Any layout. So I can go to a designer, they can give me a beautiful Figma file, I can export that to pixel-perfect HTML and CSS, and just use that.
Yes. Or you can use an AI image generator to make a beautiful, flashy, unique landing page. You take that raw HTML and you bind it to the Fractal controls.
What does that binding process look like? Is it complicated?
It's essentially adding small data attributes to your HTML tags.
Yeah.
You might have a beautifully styled div in your designer's HTML. You just add an attribute like databind name to it, and Fractal will automatically connect that div to the name field in your data model.
So the designer has total freedom to make it look however they want, and I just come in afterwards and hook up the pieces to the data brain.
That's the concept. They call it facelifting. You can clone a beautiful design from anywhere, apply it to your logic like a skin, and the back end doesn't care at all. The underlying dimensions, your security, your validation, they all still work perfectly because they're wrapped around the data, not the UI. You're just changing the makeup on the face.
That is a massive distinction. Most low-code platforms, they try to give you this drag-and-drop designer that's almost good enough, but you can never get it to look exactly right.
You're always fighting with it.
Fractal is just saying, look, CSS is a solved problem. Use whatever HTML you want from wherever you want. We don't care. Just hook it up to our brain.
It stops trying to compete with the entire world of web design and just embraces it. And this means you can have a level 3 raw UI for your customers, a level 2 customized UI for your internal managers, and a level 1 automatic UI for your system administrators, all running off the exact same data model and business logic.
I feel like we've been talking about the theory for a while now. I really want to verify some of these incredible claims with the gallery examples from the source text, because the line counts you mentioned earlier are, they're suspicious. 40 lines for a full cinema app? That just sounds wrong.
It sounds impossible, I get it. But let's actually look at that Seasons app example from their documentation. It's meant to be like a Netflix or an online cinema portal.
Okay, what are the features?
It has paging, so you can scroll through movies page by page. It has a search bar. It has video previews that pop up. It has user roles, so guests see one thing and administrators can see something else.
That's a decent feature set. That would be thousands of lines of code in a typical stack.
And in Fractal, the C# code for this is approximately 40 lines.
40. 40. I just can't get over that. How? Where's all the logic?
Because the C# code isn't doing the work. That's the key. The paging isn't a complex loop in the app code. It's a pagination dimension you attach to the movie collection. You just turn it on with one line of config.
And the search.
The search isn't a complex query builder with a bunch of if statements. It's a filter dimension. The security that differentiates guests from admins is a security dimension.
So the C# file, what you call the application layer, it's just a conductor for the orchestra. It's not playing any of the instruments.
That's a perfect analogy. It just says, open this form or apply this filter to the collection. It's declarative. It described what you want to happen, not how to implement it. The dimensions are the actual musicians doing the work.
And I saw another example in there, the to-do list app.
Ah, the classic developer example.
Right. And they claim it's basically one functional expression.
It is. The data model is just a simple JSON structure for the to-do items. The code to open the form to manage that list is literally one line. Modify first talkoff, to-do list.openForm. That's it. That one line gives you the grid, the add button, the delete button, everything.
What about the fuel calculator example? That sounded interesting.
That one is a great showcase of the reactive logic. Imagine a simple form. You have an input for distance, an input for fuel efficiency, and it calculates a total price.
Okay.
In a normal web app, you'd have to write a JavaScript event listener that fires every time one of the inputs changes. Then it reruns the calculation and updates the price field.
Right, on change handlers everywhere.
In Fractal, you handle that with a computed dimension. You just write the formula once in your JSON configuration at distance, at price per gallon. You don't write any event listeners. The platform understands the dependency and automatically updates the price field in the UI whenever the distance changes.
It's like Excel formulas, but for a full-stack web application.
It is remarkably spreadsheet-like in its reactivity. It's a very powerful concept.
And the ultimate proof of the platform's capability, the ultimate eating your own dog food example, is Fractal Cloud itself. The platform used to host and manage all these apps is, in fact, written in Fractal.
Bootstrapping, yes.
I find that fascinating.
The source says that about half of the platform is written in the platform. It handles its own Jira-like task management system, its deployment pipelines, its monitoring, its user management. All of it is built using these same dimensions and documents.
That's usually the sign of a very mature language or platform when it becomes self-hosting. That shows a lot of confidence.
It really does.
Now, before we start to wrap this up, I have to ask about testing. Because if I'm building my app by configuring all of this stuff in different JSON files, how on earth do I test it? How do I make sure I haven't broken something when I add a new dimension?
That's a critical point. In a system this dynamic and declarative, manual testing would be an absolute nightmare. So Fractal includes auto testing with a built-in recording feature for what they call user macros.
Like a macro recorder in a video game or in Photoshop?
Very similar. You, as a developer, press the record button. Then you perform an action in the UI, you create a new user, you add a post, you try to delete a comment that you're not allowed to, then you hit stop.
Okay.
The system saves that entire sequence of actions, the clicks, the inputs, the expected outcomes, as a test scenario. You can then add this to your test suite, and the system can replay it automatically after every single deployment to ensure nothing has regressed.
But what about things that change, like the current time or a randomly generated user ID? Those always break automated tests.
This is the clever part. The testing system includes what they call a time-back machine.
A time-back machine. Okay, are we time traveling now? This platform just keeps getting crazier.
In a testing context, yes. One of the hardest things to test is code that depends on now, the current time, or on random identifiers like GTADs. Because every single time you run the test, the time is different, the GUID is different, so the test fails, even if the logic is correct. It's non-deterministic.
Flaky tests. They are the absolute worst enemy of a developer. You end up just ignoring them.
Exactly.
Yeah.
Fractal's testing environment handles these non-deterministic variables. It effectively mocks the system clock and the random number generator during a test run. It makes the test perfectly repeatable. You can ensure that your update didn't break the create user flow down to the exact millisecond response and the exact GUID that was generated.
That is a seriously powerful feature that usually requires expensive third-party tools and a lot of custom setup. And here it is, just part of the platform.
It's baked right in. It's considered a core part of the development loop.
Okay, so let's zoom all the way out. We have a system that uses recursive fractal geometry to organize data and logic. It splits that logic into these dimensions to keep the core code clean and simple. It generates a functional UI automatically, but then lets you put makeup on it to make it beautiful. And it's apparently so efficient you can write a cinema app in 40 lines of code.
That's the summary.
The source article that we've been referencing was titled Programming That No Longer Exists. It's a provocative title. Is this actually the end of coding as we know it?
I don't think it's the end of thinking or problem solving, but it might be the end of plumbing.
The end of boilerplate.
Exactly. I think we're moving from a world of writing code to a world of configuring behavior. And if we want to connect this to the bigger picture, the real competition for something like this isn't just other tools like Bubble or Wix. The competition is artificial intelligence.
AI can write code now. We've all seen it. We've all used it.
We have. But AI really struggles with massive, complex spaghetti code projects.
Hmm.
It hallucinates, it introduces subtle bugs, it completely forgets the context from 5 files ago. It's not great with the kind of code most of us have to work on every day.
True.
Fractal seems to be betting on a kind of symbiosis. AI is incredibly good at writing JSON. It's also very good at writing short, declarative, functional logic.
So you're imagining a future where you tell the I need a social network for cat lovers with these specific security rules.
Exactly. And the AI doesn't spit out 10,000 lines of Python and React. It generates the JSON data model. It adds the security dimension JSON. It adds the validation dimension JSON.
So the AI becomes the architect's assistant, drawing the blueprints with perfect clarity, and Fractal is the automated construction machine that builds the house instantly and flawlessly based on those plans.
Precisely. The code that the AI generates is human readable, it's compact, and the platform executes it predictably, without bugs. It turns the act of software development into a conversation about data models and business rules, rather than a frustrating battle with syntax and servers.
That is a really powerful vision. It really does move us from being the bricklayers to being the architects. So, for the developer who is listening to this today, usually at the end of these, we say, go learn Python, or you should really check out this new JavaScript framework. What's the call to action here? What's the takeaway?
I would say, try to think in dimensions rather than in modules. That's the mental shift. When you look at your next project, don't immediately think, okay, I need to build a security service class and a user controller and a validation helper.
Stop thinking about the files and the classes.
Yes. Instead, think security is just a layer. It's an aspect that wraps my user data. Validation is another layer. Imagine a project where adding security doesn't mean rewriting half your classes, but simply adding a new clean layer to your Fractal. It's a fundamental shift in mindset from imperative, do this, then do that, then do this, to declarative, this is what I want to be true.
This is what I want to be true.
I really like that. It's been a genuinely fascinating deep dive into a completely different way of thinking about how we build software. And whether Fractal itself is the future or just a stepping stone on the way to something else, it definitely challenges the status quo of the Lego world that most of us are living in.
It absolutely does. It asks some very fundamental questions.
Well, thanks for listening. Keep diving deep, keep thinking in dimensions, and maybe, just maybe, your next project will be a fraction of the work. We'll see you next time.